Hello all. In this lecture, we will discuss the canonical decomposition of a positive integer, mainly the composite numbers. Okay. So before stating the canonical decomposition, by our theorem, by the fundamental theorem of arithmetic, we have proved that every integer n greater than or equal to 2 is either a prime or a product of primes, not necessarily distinct, isn't it? A product of primes. And such a factorization of composite integer into a product of primes is called a prime factorization. So such a factorization of a composite integer n, such a factorization of a composite integer n uh, into primes is called a prime factorization of n. Okay, so such a factorization is called the prime factorization of n. Okay, now what is the difference from this prime factorization and a canonical decomposition? Or if we write this factorization, for example, first we consider the number. Suppose we consider some small number. Let this be uh, 2520. Okay, no, some simple smallest number, that is 60. So first of all, we take n is equal to, let n is equal to 60. Okay, n is equal to 60, and 60 we can write it as 12 into 5, or 12 we can write it as 3 into 4 into 5, or we can write this as 3 into 2 square into 5, or first of all we can write it as 3 into 2 into 2 into 5. Okay, so this is 3 into 2 into 2 into 5. This is a factorization into primes. Okay, so this we can say that this is a factorization of 60 into primes, or prime factorization of 60 is 2 into, we can write it also as 3 into like this. Okay, so this is a prime factorization of f. No need in the prime factorization of n. There is it is not important that the numbers are in decreasing, or sorry, in ascending or increasing order. But when we talk about the canonical decomposition, it must be we have to say that this number 60, we can write it as product of prime power factorization. First of all, we have to write this as 2 square into 3 into 5. That means the primes in this factorizations are distinct. But in prime factorization of n, there is no need to write this as a power and in distinct form. But when we say the canonical, it is a canonical decomposition, we have to remember two things. First of all, we have to find the how many times a prime number is repeating in that prime factorization. Okay, then first write the smallest prime. That means write the expression in the increasing order of the primes. And each primes must be distinct. Each PIs are distinct in this factorization. So such a factorization is called a canonical factorization. So this is the canonical factorization or canonical decomposition. Okay, so let's again write the definition of canonical decomposition. Okay, definition. The canonical decomposition of a integer of a positive integer n is of the form n is equal to some p1 raised to alpha 1 into p2 raised to alpha 2 etc. into pk raised to alpha k, where p1, p2 etc. pk are distinct primes. Underline distinct primes and are distinct primes in which or with distinct primes with p1 less than p2 less than etc. less than pk, and each exponent alpha I is a positive integer. So this is the canonical decomposition of an integer or a composite number into primes. Okay. Now we will see some problems how to find the problems. Okay. Example 1. Find the canonical decomposition of number 2520. We know that in 2520 it's a even number, so we first divide this by 2, then it will be 1 2 60, then again by 2 it is divisible 6 30, again it is divisible by 2, then in 3 it is 1, then 10 it is 5. Now divisible by 5, then 63. Now what about 63? 63 we can write it as it is divisible by 3. So 3 when we divided by 3 it is 21. Again divided by 3 it is divided by 3, then we will get it as 7. Now 7 is not divisible, 7 is a prime number. So we have to stop at 7. So 2520 we can write it as 2 into 2 into 2 into 5 into 3 into 3 into 7. Okay. So again we can write this in the canonical decomposition. We have to find the canonical decomposition. So first of all, take the powers 2 repeats 3 times, so 2 cube into now the next prime number coming in this product is 3. So 3 repeats twice, so 3 square into 5 comes only once, then 7. So this is the required canonical decomposition, that is 2 cube into 3 square into 5 into 7. So we can draw this tree diagram for this problem. First of all we have to write the number in the top. So number is 2520, and 2520 we know that it is a product of 40 and 63. So 40 divides 250, so we will draw one line segment here. So also 63 divides uh, 63 divides 2520, so 63. Now 40 we can write it as 4 into 10, or 4 divides 40, and hence 4 divides 2520. Also 10 divides 40, and hence it divides 2520. Now 63 we can write it as 7 into 9. Okay. Now 4 we can again write it as 2 into 2. Now 10 we can again write it as 2 into 5. 7, there is no further factorization is possible since it is a prime. And 3 we can again factor as 3 into 3. Now we have obtained all the prime factors, all the possible prime factors. So we can write 2520 in this as 2520 is equal to 2 into 2 into 2 into 5 into 7 into 3 into 3. That is again rewriting this in the canonical decomposition: 2 cube into 3 square into 5 into 7. So this is the required canonical decomposition. Okay. Equal to 48. So there are 48 positive divisors for this number. And for 60, we have already found that it has uh, 12 positive divisors. So this is about the canonical decomposition and the number of prime factors.